The file transfer is similar to a job that can be used to automate agent-to-agent FTP processes without an FTP server. It is secure, fast, it can be audited with a full array of the Automation Engine supervision tools. It requires no particular technical knowledge of FTP technology. If you've used FTP before, you will easily recognize the attributes associated with this object type: agents of origin, agents of destination, file attributes, compression types, and more. It's worth mentioning that an agent is required on both the source and destination hosts. In the video, we have two agents running on two hosts. The source agents will be a Linux system with some files in a specific directory. The destination will be a Windows system. We run the job F objects to transfer the files from one to the other. We open the process assembly perspective, which is the perspective dedicated to configuration design. We always recommend creating folders for each object type to keep the environments organized and tidy. In the list of objects, we find job F, or the file transfer. We recommend using the title field, which makes viewing and searching objects much easier. In the file transfer page, we find three main categories: source settings, destination settings, and transfer settings. The settings for the job F object are intuitive. For the source, you indicate where the files are located and who is submitting the file transfer. The login object does this. Login objects contain the credentials that agents need to submit processes to the target systems. Page code settings are occasionally required for more exotic systems that don't rely on standard ASCII character code sets. In our case, it's not relevant since neither Windows or Unix fall in that category. In the file fields, you indicate the files you want to transfer and their location. You can use wildcards for both the file name and the directory. In the file attributes field, you can enter additional attributes that are specific to the operating system, in our case to Windows or Unix. You can also enter formatting commands here. For example, in files with multiple lines, you may want to specify how line breaks should be formatted when transferring from the Windows to the Unix system. In the destination settings, we enter the same type of information. You are required to specify a file name in the file fields or the transfer fails. Names do not have to match the source names. Finally, we have transfer settings. Just like FTP, you can choose between text and binary usually works for text. During transfer, the file attributes may change to adapt to the target platform, but you can check the Keep Original File Attributes checkbox to prevent it. Then the engine provides compression capabilities which are optional. You have the option of setting the behavior in the event the file exists at destination. You can cancel the transfer, overwrite the file, or append the data to the existing file. You also have the option of erasing the source file when the transfer completes successfully. Finally, if you use wildcards, for example to transfer more than one file, you have to check the appropriate box. Before we begin, we just want to show you the system reality behind the scenes. This is our Linux host. The files are found in /opt/atomic. We have 5 files numbered sequentially. On the Windows host, we're going to transfer to the temp directory. At this point, all we have to do is configure the file transfer. Notice the use of the wildcard. We want to transfer all of those files. We are creating new files with different names. You have the option of compressing, although the default value is no compression. These are the options in case the file already exists at destination. You can cancel the transfer, which appends, overwrite the file, or append the contents. We check this box since we're using a wildcard. This gives us additional options. When we check the option, we see several new options. Abort at first error appends the transfer if the first file fails, for example, if it already exists. If you do not check this option, the engine will move on to the next file, then the next, and so forth, until it reaches the end. You can also include the subdirectories. If a directory matches the settings in the file fields, not only will those directories be transferred, but the engine will drill down and copy everything inside them. Finally, if you want, you can transfer the entire substructure of the directory. We can now execute our file transfer. Since the two hosts are images on the same system and the file volume is very small, we can assume that the transfer is instantaneous. We check the reports. The report contains useful information. It shows the filter, in other words, the text of the source file fields. Anything matching that requirements will be transferred. The 5 data files do. Lower down, you see the files transferred along with the other information. The names of the new files, the size, and duration. In Windows, we have 5 new files per the options we selected. Let's consider a practical application of the file transfer. We use it in a workflow which extracts data from an application on our Unix agents, moves that data to the Windows system, where it is inserted back. The initial framework of the workflow exists, but we need to insert the file transfer. We simply go to the object list and add our job F, then connect it to the predecessor and successor. We execute and then supervise in the process monitoring perspective. Immediately, we notice that the file transfer failed. Let's pull up the report. The error is obvious. The files already exist on the Windows host from our previous transfer. Since we indicated we wanted to cancel the transfer if this was the case, and abort on first error, that is exactly what the engine did. Remember that the automation engine also supports multi-browser design. You have the option of having 2 browser windows open side by side and drag and drop objects back and forth. This is particularly useful for adding file transfers to workflows.